What's up? What's up? It's your man Jimmy Chan. All right, so we are looking at diagonal lines. So diagonal lines are lines, especially if we're looking at an equation. There's x and y's in it. However, better yet, in order for us to write the equation of a line, we need a slope and a point, always. Okay, so we could be given 2 points. Well, with 2 points, we can find a slope, and then we also already have a point. We actually have 2 points, but a point would be worthwhile. So here are the different forms that you can see: the general form, the point slope form, the slope intercept form. All right, and any diagonal lines has an x and y in the equation. All right, so slope we know as rise over run, right? So if the rise is positive, we move up. If the rise was negative, we move down. If the run is positive, we move to the right. If it's negative, we move to the left. All right, and we also know it as this formula here: y2 minus y1 over x2 minus x1. So as we travel from left to right on our graph, right, from left to right, as we travel, if it's going upward, then we have a positive slope, right? The function is increasing, we have a positive slope. If it's decreasing, then we have a negative slope. If it stays the same and constant, then we have a zero slope, because we will have zero fun if we're skiing on this slope. And if it's a vertical line, then there's no slope, or the slope is undefined. All right? So parallel and perpendicular lines. So parallel lines, if I had two lines that were parallel, it would look something like this, except obviously I would change the color so that it look different, right? So parallel lines are lines that actually have the same slope but different y-intercepts, right? That's what we do know about parallel lines. Now, however, the slope is the same. The slope is the same, okay? So we do have to remember that. Now, perpendicular line, as you guys can see right here, this looks kind of weird, right? What do you mean that thing, right? So I put it down as flipped and negated. So meaning, if the given slope was, let's say, 2/3, then the slope that's parallel to that is going to be same thing as 2/3. However, the slope that is perpendicular, that slope is going to flip the 2/3, which would be 3/2, and negate it. Since this is positive, we're going to make it negative. Now, if this was negative, then we will make it positive. Okay? Let's try another one. Let's say it was -5. If it's parallel, then it's still -5. But if it's perpendicular, again, we can write this as a fraction. That's -5/1. Flip that would be 1/5. Negate it. Since it's negative, is now positive 1/5. So that is what this is trying to say about flipped and negated. Okay? And again, just as a reminder, perpendicular has this symbol right here. And parallel has this symbol here. There we go. All right, so that's the difference between parallel and perpendicular. All right, so hopefully that helps. Let me see here. Now, what about horizontal and vertical lines? So one of the things I say to you is that horizontal lines have zero slope, right? So the slope is 0. So for me, when I draw a horizontal line, I like to just plot 2 points, right? When I plot the 2 points, now I can look at the 2 points and say, okay, what stayed the same, right? What stayed the same? Well, as you can see here, the 2 stayed the same. And what value is that? That is the y value. So we should have y is equal to 2 here for that equation. So this right here should say y equals b. Okay? And then for the vertical, same thing. I would, again, pick 2 points and go, okay, what stayed the same? The -3 did. Okay, and what values are those? X equals -3. So same thing here. This should go away, and this should say X equals A. There we go. All right. And looks like that is it. That's what I was going to do. Let's do an example. Putting all these things together, let's say that we want to write an equation of a line. So write an equation of a line that goes through three, 4, and is perpendicular to x minus 4y equals -1. Okay, so I have to write an equation of a line. To write an equation of a line, I need a point, which I have, 3, 4, and I need a slope, which I don't have yet. Okay, so to find the slope, however, I'm going to look right here. This tells me that my line is going to be perpendicular to this line. So if it's going to be perpendicular to this line, I want to know what their slope is. So in order to get the slope, I want to get the y by itself. So y is going to equal to 1/4 x plus 1/4. So in that case, my slope here is equal to 1/4. Well, the question is, what is the slope that's perpendicular to that? Well, let's flip that, which is 4/1. Negate it is positive. It goes to -4. From there, I can bring that with me, right? And replace that question mark with an actual number. Now I can write the equation of my line. So I can use the point slope form if I want to. And if that's the case, I'll have y minus the y value, which is 4, is equal to m, -4, times x minus the 3. So I got y minus 4 is equal to -4x plus 12. So y is going to equal to -4x plus 16. And that would be the equation of my line. And that would be the equation of my line. And if I wanted this in function notation, then it would be f of x is equal to -4x plus 16. There you go. And don't forget that this form right here would be it if it was asking for point slope form. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.